Hi friends, today we are going to see uh, whether the following given function satisfies the Cauchy Riemann equations. The given function is this and also find its differentiability. The function given, as you can see, this is the function z5, z raised to the power 5 over modulus of z4 when z is not equal to 0 and the function is 0 when z is equal to 0. You all know the CR equations and this is the derivative formula, right? So we'll find the answer now. In order to find the derivatives, we'll use the limit definition, which is limit h goes to 0, ux plus h, comma y. This is the formula as we all know. We simply replace the value of x with h. We get this quantity, h5 over h4 over h, which is simply 1. And for partial u over partial y, it's simply 0. There is no y in this function. Like in the u xy, there is no y, so it's simply 0. Similarly, partial v over partial x is 0. And partial v over partial y is this formula, which is like k4 by similarly k4 over k raised to power 4 over k4 by k, which is simply 1. This is very clear and simple calculation, and hence we can conclude that partial u over partial x is equal to partial v over partial y is equal to 1, and these are all zeros. So the CR equation satisfies at the origin. Right, now we find the partial derivative of the function. Derivative of the function, which is like at 0. So the formula here is to find f dash 0, we use the limit formula once again. We all know z is equal to x plus iy. We can write in the polar form, and using the Euler's formula, we can write like the expression like this. Hope you understand that this part. There's nothing. Now, where r has to be considered greater than 0, so that we don't get a 0 in the denominator, and theta belongs to a set of real values. So we can write limit r goes to 0, this quantity over this quantity and this one. So we get this over this and this. This r e raised to power I theta raised to power 5 over modulus of r e raised to power I theta raised to power 4 and r I theta. Now this thing, how this thing has to be calculated, I will show you. The limit. This portion is 1 basically. As we all know, this portion is 1. So I can do the calculation here. E raised to power I theta is equal to 1 because E raised to power I theta is equal to modulus of cos theta plus I sin theta. And we all know modulus of cos theta I sin theta is equal to root over cos square theta plus sin square theta, which is nothing but 1, isn't it? So this quantity is 1. So what we get here, this quantity is 1, right? As we know from the calculation. So we can write r e I theta r4 to r I theta. Basically what we get, this r5 over r5 and here e I4 theta. This cancels out. We get basically e I raised to power I4 theta, which is definitely not equal to 1 because we know in the CR equation we have to partial u over partial x that we have calculated at 0 0 plus I partial v over partial x at 0 0. We have calculated this one earlier, was already 1, right? So this value is not equal to this value. this value is not equal to this value, right? Hence, the function of f of z is not differentiable at 0, 0. It satisfies the CR equations, but function is not differentiable at 0, 0. Hope you get the calculations here. Very simple. We convert it to polar form, then to, we can directly do this using the Euler's formula, and we have to write this, consider r greater than 0. So we can write, and theta belongs to all real values. When theta belongs to all real values, we get e raised to power I, theta is equal to 1. And from here, we get the calculation. Simple calculation gives us this end value is e raised to power I 4 theta, which is not is equal to 1. Hence, it is not differentiable at the origin. Thank you for watching.